Morning, everybody. Sorry I'm a little bit late here. Had a sign-in issue.
Good morning, Professor.
Morning.
Morning.
All right. So what we're doing is going through this sample test here, which, by the way, is the same as the real test you'll be taking. I don't know. Well, actually, probably if you're here, you probably haven't taken it yet. Wouldn't make a great deal of sense for you to come today if you've already taken the test. So if you've already taken the test, I don't know why you're here, but if you want to be, that's fine, I guess. So everybody's clear on the fact that you can take this test anytime up until the due date, which I think is, well, let's have a look, make sure that we are understanding this. Okay, so according to the schedule, today we're doing a review and the test is going to be due next Monday. There won't be class next Monday, by the way. The homework will be due on Sunday at 11:59 p.m. So just keep that in mind. All right, does anybody have any questions about what's going to go on here? All right, so no class on Monday. It's just a reflection of the fact that I'm being realistic, that most people usually wait until the last day to do it. I'm not sanctioning that. I'm not saying it's a good thing to do, but it's what a lot of people do. So it's not my cup of tea. There's also an extra credit opportunity as well. That is, if you take this very test that we're going through, and you get 80% on it, then you have to do that by 11:59 p.m. on Sunday. Then you have that opportunity to get that extra credit. Again, that's my way of trying to force people to take it early. As I said, like a third of the class generally gets that extra credit. I think it's crazy because it's such an easy way to get points, and you have to do it anyway. I don't understand why not just do it. It's always been my thought, but anyway. All right, let's see what we're doing. We're up to module 5, I believe. So in module 5, you do have the polyatomic ion sheet here, that you'll be able to access just by scrolling back up to it. Then you've got your periodic table of the elements here as well. All right, so then it's just a matter of recognizing what kinds of compounds you're dealing with. In this case, we're dealing with a 2 non-metal compound. You can see it's got N and O, so they're both here in the non-metal section. So it's one of those that's going to be named using the prefixes, so dinitrogen pentaoxide or pentaoxide, whichever one matches here. Let's see if it's going to be even here. And if it isn't, then you would do none of these. And I think this one might be none of these. So if some of them are none of these, and you have to be mindful of that. Does anybody have any questions so far? Okay. This next one, RB2S. So you look at where they are on the periodic table. RB is on this side, S is on this side. So it is a binary compound. Rubidium's in group 1, so it's always got a set charge of 1+. So it would just be rubidium sulfide. Anybody get any questions? Now, the reason it's not dirubidium sulfide is because, or dirubidium monosulfide, is because it's a group 1, and we already know that its charge is 1+, so that's what it has to be. This next one, PbClO2, so you look at ClO2 and you find out what that is, and ClO2 is chloride and it has a -1 charge. And you can see there's 2 of them, so it must be lead 2 chloride. Any questions? All right, this one is Ra and HCO3 2. So we go back up, we find out what HCO3 is. We can see it's bicarbonate or hydrogen carbonate, has a -1 charge. But it is radium, and radium is down here in group 2, so it's already got a set charge, so no Roman numeral. So it's going to be radium bicarbonate or radium hydrogen carbonate, and that would be the answer you'd put down there. Any questions? Okay. The next one, FeBr2. So we know that it's Fe and Br. Now Br is in group 7, so it's -1. There's 2 of them, and iron is over here. So it'd be iron 2 bromide. So you'd look for iron 2 bromide, and it isn't there. So you would say none of these. Any questions?
I have a question.
Yeah.
Why wouldn't it be bromate?
Because Br, as it's in and of itself, is just bromide. Now bromate, I'll show you what bromate is. Bromate is up here. It's BrO3 minus up here. See that? Bromate. That's a polyatomic ion. All of these end in IDE. Fluoride, chloride, bromide, iodide, oxide, sulfide. You know, they're all those elements with the IDE suffix.
Oh, okay, thank you.
Next one. Oxygen difluoride, so that would be OF2. Tin 4 bromide, so that would be tin 4 plus, and then bromide, which is Br minus, so it'd be SnBr4. Cesium cyanide, cesium, and then cyanide is Cn minus. So look at what cesium is up here. Cesium is 1 plus, is in the group 1, and Cn is cyanide, that's 1 minus. So CsCn would be the answer. So you just find CsCn amongst those answers, hopefully. There it is. If it wasn't there, then you hit none of these. Aluminum arsenide, so that's going to be arsenic with the arsenic is the element, so AlAs, but it would be, let's see, aluminum. Let's go back to where aluminum is. Aluminum is in group 3. Arsenic is in the group 5, so there, that's 3 plus. The Al is 3 plus, the As is 3 minus. You just need one of each, so it'd be AlAs. There it is. Anybody have any questions so far? Aluminum bromide, so it'd be Al, which is 3 plus, as we just talked about. Br is -1, so it would be AlBr3. Any questions about that one? HMNO4 acid, so this one has to be named as an acid because it says acid next to it. The MNO4 is the anion, and MNO4, according to the polyatomic ion sheet, is permanganate. So it would be permanganic acid. So 8 goes to ic. So it would be permanganic acid would be the answer to that one. Any questions?
I have one.
Yeah.
Yeah, Joseph.
You can go first. He can go first. It's fine.
Okay.
How is it permanganic acid?
Because it's HMN, because MNO4 is permanganate, That's what the name of the anion is. And if it's an acid, then the 8 goes to ic acid. If it was ite, it would go to us acid.
Okay, thank you.
Okay, and permanganate is in the polyatomic
Yeah,
ion list.
I just pointed it out, Joseph. I'll show it to you again here.
No,
Right.
yeah, okay. I got it. Thank you.
So I just hunted down MnO4 and found the name, so there wasn't really any real mystery to it. Bromic acid. So bromic comes from bromate. If it was hydrobromic, it'd be HBr, but it's not hydrobromic, it's bromic, which means it comes from bromate. And if we look at what bromate is up here. That's BrO3, so it'll be HBrO3 for bromic acid. All right, does anybody have any questions? That's how Module 5 is going to be set up. Yeah, the best way to practice it is just to do that sample test until you're getting the right answers all the time, making sure you're seeing all the patterns, understanding how to get the charges on things. I mean, that's what we've talked about in class. That was the main focus of it. Any questions? Okay, so Module 6. What is the sum of coefficients of this reaction after balancing? So this is just a straight balancing problem. Let's see how we go about doing that. Just going to untwist my audio cable here. Okay, it's a little bit better. I can already see what I'm not going to touch first, and that's the oxygen. There's just too much oxygen going on here. All right, so you've got way too much oxygen, so I would start off with the PB. PB is one of each, so that's okay. Mg, that seems okay so far as well. Chlorine, though, we've got 2 chlorines over here. We need 2 on this side. Now we're in a position to be able to count things up, and we've got 2 oxygens on the left side, and it looks like 5 now on the other side. So I can't fix this by just putting something in front of the O2 over here. I'm going to have to make some adjustments. Now I don't really want to put anything in front of the Mg because that'll change the Cl over here as well, but I might not have a choice. At some point I might have to do that. Well, maybe that's what I will do then. I'll put a 2 in front of the Mg here. That'll need a 2 in front of the MgCl2, and that means that 2 there will have to turn into a 4. But now at least I've got an even number of oxygens to work with. I've got 2 plus 8 is 10. So if I put a 5 in front of the PbO2 over here, that'll be good. That'll give me 10 oxygens. And then a 5 in front of the Pb here, and then it should be balanced. So the sum of coefficients there would be 5 plus 2 is 7, plus 2 is 9, plus 4 is 13, and 5 is 18. So the answer would be 18. Does anybody have any questions about number 24? Any questions? Okay. So the next one is a hydrocarbon balancing. Now, if you'll remember when we went through this in class, what I had said is you'll know if you need to multiply by 2 or not by looking at the number of hydrogens. So we divide that by 2 and we see if it comes out to be an even or an odd number. In this case, 16 divided by 2 is 8, which is even. So I know I'm not going to have to multiply by 2, which is good information for me to have. 7 C's, 8 waters. 7 times 2 is 14, plus 8 is 22. So 1102 is what I'll need there. Sum of coefficients, 1 plus 11 is 12, plus 7 is 19, plus 7 is 27, plus 8 is 27, sorry. So 27 would be the answer to that one. Does anybody have any questions about balancing the hydrocarbon? Remember, this is your time, folks. If you I completely understand, that's fine, but if you don't, you really need to ask questions. Okay. Right, acid-base reaction. So you can see we're getting water out of this. That's a good clue for you. So what I like to do there is to draw pictures of each of them, so I'm very clear about what the anions and cations look like. So that would be FeOH3. So 3 OHs, each -1, which means the Fe is 3+. Then we've got HI. H is 1+, I is 1-. So we know that the water is coming from the combination of H+ and H2O. Sorry, H+ and OH-. That'll give us H2O. And the Fe3+ is joining with the I-. So that would be FeI3 to balance out that compound. Does anybody have any questions?
How again did you get H2O?
From the H+ and the OH-.
Okay, so you're just using one OH from.
You have to. That's right. When you're trying to figure out these compounds, the compound A and the water, you base it on the combination of just one of each anion and cation. You don't you don't add everything together and say, well, that's going to be H4O or something like that. It doesn't make any sense.
I see. Okay, thank you.
All right. Any questions? So the next one is a double displacement, similar to what we just did, but now you're not getting water as a product, you're getting something else. So we do the same thing with that one as we did with the previous one. And what we do, actually I won't put charges on yet. We know that it's Ag and NO3, that would be one picture, and the H2S would look like H, H, and S. NO3 has a -1 charge, that means that silver is positive. S is -2 and H is 1+ each. Does anybody have any questions there about how I'm getting the charges? All right, so we join them together. That'll be H and H+ and NO3-, which would be HNO3. And the other one is Ag+ and S2-, which would be Ag2S. So it's insides and outsides, and again, combine one of each in order to figure out how to balance the compound. You'll notice, I think H2NO3 is an answer here, and I've put that in there deliberately to catch people who don't understand what they're doing. At least I hope I have. No, I didn't. No, I should. So HNO3 and Ag2S would be the answers there. Does anybody have any questions? Okay, so the next one, this is the full ionic equation. You're given a balanced equation to work with. And again, my recommendation is to draw out pictures of these. So two, and put them in little boxes because you know you got that many of those boxes containing those. So do 2FeNO3 S3. And we can also put charges on, but we don't really have to answer this question, but I'll do it anyway. So negative, negative, negative on the NO3s, 3 plus on the Fe. Right. MgOH2 would be Mg and 2 OHs. Now these are aqueous, so I've split them up into ions. Now the other one, this one here is FeOH3, but it's a solid. So I leave that one alone. Oops. But that's a solid. So I don't touch that. And then the other one is MgNO3, and there's 3 of those. MgNO3 2. Okay, now I can count the actual ions because this will be the sum of the coefficients here. So that would be a total of 2 times 4, that's 8. 3 times 3, that's 9. We got 2 here on the solid, and then 3 times 2 is 6. So 8 plus 9 is 17, plus 8 is 25. Would be the answer. Does anybody have any questions? I can't believe nobody has any questions about this. This question is usually pretty poorly done.
So did you get 25 by adding and multiplying?
Well, just by, well, sort of. I mean, if there's two, think of this as being 2 boxes containing an apple and 3 oranges. And what I'm asking is the total number of apples and oranges, which would be 2 boxes containing those, which would be a total of 8. That's where I'm getting that from. And then just adding all that together, yes.
Thank you.
Would that be the best way to make sure you're able to find the right number of coefficients?
I'm sorry, could you repeat that, please?
With the boxes. You think
Well, I don't know. If you've got a better way, you can use it. You know, it's up to you. I don't know. That's just I think that's the easiest way of doing it. But if you've got another way of doing it that you think is easier, you should use it. Yeah.
No, I was just double checking because
Okay. Well,
I was all confused.
Well, not that I like to quote Dr. Phil, but Dr. Phil says that 85% of questions are actually statements in disguise. So I'm not sure what statement you're trying to make there, but if you think that's a poor method or not.
Or no, it looks like it works. I was just double checking to make sure, like, if it was consistently gets the right answer.
Well, do you think I'd try and teach you a method that wasn't consistent? I would hope not. I'd hope not. No, but the main trap that people fall into, Jacques, is that they don't, or they take the solid and they try and split that up as well. But the solid is the solid because it's solid. It doesn't split up into ions. So you can't split that apart.
Okay.
Maybe that's where you were sort of having some doubts about it. But that's the thing. The solid doesn't get split apart because it's a solid. That's the whole point.
I think that might have been the part.
Okay. All right, anybody got any other questions about that one? All right. Now this one is looking for the net ionic equation, and we talked about this in class. And what we noticed was that the net ionic equation is really what is making up the solid. So what do we need to make up this solid? Well, we need Pb and we need 4 OHs. Everything else is going to cancel out. That's negative, that's going to be 4 plus, but the answer would be 6. 1 plus 4 plus 1 is 6. Any questions? That's how easy those net ionic equations are. That's all you have to do. I mean, I could go back. Actually, I can't go back now and show you that. But with the other one, the other way of doing it is to cancel out any ions that are the same. But effectively, that's what you're doing anyway, because whatever's left is whatever's not forming the solid. That's what ends up being cancelled out. Does anybody have any questions?
So you could just pull exactly those things and don't even have to worry about it. Just
Yeah, Joseph.
oh, wow.
Oh, look, you can't sit here and say, oh, he's teaching us the hardest way of doing. No, I'm not.
No, I'm not saying that. It seems so easy that I'm like,
well, that's the difference between people who turn up to class and people who don't, Joseph. They get all this good stuff. So,
yeah.
Everybody who's here, you need to pat yourselves on the shoulder and say, you know what? It was worth it. It was worth getting out of bed. Yeah. All right. Any other questions? All right. The ions on the reactant side of the full ionic equation. So this is where you actually do have to figure out some charges. So what I like to do, we're only on the reactant side, right? So that's the K2SO4 and the CrCl3. We don't care about how many of those we have. So we're going to draw pictures of them. So we've got K2SO4, we've got CrCl3. The coefficients don't matter for this one, because we're only interested in the ions of the charged particles. Negative, 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 that's going to be 3 plus. SO4 is negative 2, and K is 1 plus and 1 plus. So the ions are going to be K plus, SO4 2 minus, Cr3 plus, and Cl minus. And that's it. You don't try and combine ions or anything else. You just take one of each, and those are your ions. So you've got to make sure you pick the right ones. K plus, SO4 2 minus, Cr3 plus, and Cl1 minus. Any questions? Everybody's hunky-dory with that, huh? All right. Okay, so for this one, this is a single displacement. We've got gold and SN4 plus essentially, because gold is going to be solid, that's going to be 0 as a charge. SN is going to be 4 plus because it's in aqueous solution. You don't have to worry about what charge it is, you just know it's charged. Is there a reaction? The answer is no, because it says no changes. Neutral element, well, that's going to be the gold. The charge, that's going to be, or the cation, is going to be SN4 plus. So which one's more active? Well, the more active one in this case will be the cation, which is going to be 10, and less active will be gold. So then you just find the one that matches that. And then you would just choose that answer. Sorry, need to drop that pen there so I can do that. There we go. So make sure you get the right one. No, AU, SN4 plus, SNAU. So that would be the one you'd choose. Does anybody have any questions? Any questions? So just to clarify there, the observation, if there's anything there but like a color change, the production of a solid, the change of a color of a liquid, change of color of a solid or something like that, that would be an indication that there was a reaction. And in that instance, the neutral element would be the more active one rather than the cation element. Does anybody have any questions? I can't believe nobody has any questions. All right. Okay, number 32, what's the sum of coefficients from the following reactions? So it's X dot 5H2O. Where X, doesn't really matter what X is, but it's going to be X plus 5H2O. So the answer there is going to be 6. Sum of coefficients, 1 plus 1 plus, actually, if I could add, 1 plus 1 plus 5 is 7, sorry, would be the answer. Any questions? What's the formula of the metal oxide? So we're not really after the whole reaction here. So we're just after the metal oxide. So X2CO3, 3. And what I would do is I draw a picture of it. We know that the product is going to be some combination of X and oxygen. We need to figure out what the charge on the X is. So that's -2, -2, -2. So that's -6, means the X combination must be +6, which means each of these must be 3+. So the combination is between X3 plus and O2 minus, which gives us X2O3. So that would be the formula. Does anybody have any questions?
Wait, sorry, my mic's muted. So you take the. Sorry, can you explain that one last time? Just because I don't know why the ding.
I'm sorry?
Can you just explain that one last time? Sorry, I don't know why that I didn't get that.
Okay. Well, are you okay with the fact that we get some combination of X and oxygen? We know we need to be aware of that first.
Yeah, I'm okay with that.
Okay.
I know that.
Now, but we need to charge on the X. So if we know that CO3 has a -2 charge and there's 3 of them, that means the total negative side is -6, which means the positive must be +6 to match it, meaning each X has to be 3+.
Okay, that was what I was just like. Thank you.
All right. Any other questions? And the last one here is, again, looking for the metal oxide formula. So it's XOH6 So X is going to be 6+, And we know, again, it's a combination of X and O plus water. We're getting its products. But the X is going to be 6 plus. The O is going to be 2 minus, which means the formula is going to be XO3. Does anybody have any questions? You can see it here. Any questions? Any questions? All right. Well, that's the last one on the test there. So that's the whole test we've gone through. So remember that the homework and the extra credit are due Sunday at 11:59 p.m. And then the test is due to be taken the following day, February 7th. I think so, February 8th. Tuesday, Thursday, Wednesday. Yeah, sorry, so today's February 8th. Okay, does anybody have any other questions at all about anything on the test?
I have a question.
Yeah, go.
It's the one we just did.
Yes.
I just keep looking at it and I'm not figuring out how there's no H's in the problem. I mean, in the answer.
Because when we, oh, sorry. Sorry, that's the last one. Sorry.
Yeah, that was 36.
No, that's all right. Well, there is the H2O here is where the hydrogens are.
Yeah. But in the
Well, look at the question though, Coden.
oh, we're only finding the solid.
The metal oxide. What is the formula of the metal oxide formed from this reaction? That's what the question's asking for.
Okay.
And that would just be the XO combination.
Okay. So the H2O is still there, just not asking for that.
That's right.
Okay, I see.
Now, if it was asking for, the sum of coefficients from the reaction, yeah, then you'd have to include it.
Okay.
Because then you'd have to find not only the formula of the metal oxide, but also then how it balanced out too.
Yeah.
So,
okay,
I mean, and that's possible for question 32. I mean, you could see that. But let's see how that would end up panning out. If we did that, Coden. So XOH6 would give XO3. We already figured that out. Plus H2O. And to balance that, we put a 3 in front of the H2O, and that will balance everything. And for sum of coefficients, there would be 5. So in that instance, then, yeah, we would need the water so that we can balance it out.
See that now.
Okay, that's all right, Code. Thank you.
Thank you.
Does anybody have any other questions about anything on the test? Anything at all?
Could you go back to, just so I can go over it one last time, the finding the sum of coefficients for a full, I believe it was the full equation.
The full ionic equation. Well, how about
Yes.
How about this? How about I re-roll?
Okay.
I hope it doesn't give me the same problem. Sometimes it does. Sometimes it doesn't. All right. Okay, so there you go. It is a different one. So what I would do, do you want me to go through it, Joseph, this one?
Yes, please.
Okay. So what I would do is I'd put a 2 outside. Again, it would be a box that contains 1 apple and 1 orange, and there's 2 of those boxes. So Cu and then 1 NO3. And then we've got the MgOH2, and that's just 1 box. And then we've got CuOH, that's the solid. And then we've got 1 more box that has Mg and 2 NO3s. Just gonna, I don't know, yeah. I was gonna shut down my Wi-Fi here because I'm on Ethernet. It might not be picking that up, but if I shut that down, I'll probably end up losing the connection, so I don't want to do that. Okay, so the sum of coefficients then would have to be, so there's going to be 4 here, 3, 2, and then 3. And that would be 12.
Okay, so that's 4 because it's 2 times the amount of things in the box. Okay.
Yeah, so let's say you had 2 boxes and each contained an apple and an orange. You'd have a total of 4 apples and oranges. In the other box, you've got 1 apple and 2 oranges, so that's a total of 3. Yeah, so that's how we're working it out.
And wouldn't, oh wait, and then it's not, wait, why is the second CuOH on the react? Why
It
is
isn't.
CuOH not 4 as well?
Because it doesn't split apart. It's a solid. It's a solid, so it doesn't split apart.
Got it. Thank you.
Okay. Any other questions?
Could you do a net ionic equation, finding some of the coefficients?
Or, in fact, you all should be able to look at that and just tell me straight away what that is. Anybody want to come up with a number?
Is it 12?
No, wouldn't be 12.
It'd be,
Is it 7?
be 211 plus 3 SiO3 plus.
No, I don't think it's 7. I'm not getting that. All right, maybe it's not as clear as I thought, huh?
Would it be 5?
No, it's not 5 either.
Yeah.
All right, so hit the solid is Al2 SiO3 3. That would need 2 aluminums and 3 SiO3s. So I get 6. Am I wrong? I don't think so. Any questions? All right. questions about that one? All right. Any other questions about the test at all? Any other? Sorry, Coden.
Can we do one of those equations? I mean, one of those reactions where it's like it gives you, like, for instance, RbClO3 plus heat, and then it does what's the compound A plus O2?
Well, that's actually not on the test. That's in the homework.
Yeah. I was gonna ask that today because I saw it in the practice quiz for module 6.
Okay, well, it's in the but it's also in the module 6 soft chalk as well. We did go through it in class, all right? I'm just saying we did go through it in class.
Mm-hmm. I just want to like refresh it because I kind of totally forgot about that.
Okay.
I think I'm on the right track, but I just want to check my work.
So what was it? RBCl plus heat?
ClO3.
RBCl. Oh, okay. RBCl is 3. Okay.
Yes.
So that gives some combination of Rb and Cl plus oxygen gas.
Yeah.
Now we need the charge on Rb is 1 plus, the charge on Cl is 1 minus. And Rb is in group 1, that's how we know it's 1 plus. Also, we know that ClO3 is -1, so Rb has to be 1 plus there as well. So the formula, the compound reaction at this point, RbCl plus O2. But now to balance that, you'd put a 2 in front of the RbClO3 to give 6, and a 3 in front of the O2 to give 6. And then a 2 in front of the RbCl.
Yeah. And
that's how you'd end up getting the right answer.
Okay, thank you.
That's okay. All right, remember this one isn't on a test. This one is in the homework, so that's what he was asking.
Okay.
All right, does anybody have any other questions? Any other questions about the test or about the homework as well, if you want to ask about that too? Well, if you haven't started the homework, I'd strongly recommend going ahead and doing that. I know some of you are going to wait until the last minute. Some of you aren't even going to get it done. But, well, so be it. Does anybody have any other questions at all? All right. Well, if nobody has any other questions, then we'll end it here today, and I'll say good luck. Get that homework done and get the test done, and try and get it done early. Don't wait until last minute, and don't just give up that extra credit.
Okay, thank you for being with us today.
Yeah, no worries. Thanks for coming.
Have a nice day. See you Tuesday.
You too. See you later.
Yeah.
All right.
Thank
Bye.
you.
Have a nice day. Thanks, Professor.
Thank
All
you,
right, no worries.
Professor.
I'll see you all later.